Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called SVS number 427, Nonodoku, by Richard, and SVS is Sudoku variant series. I just actually realized that. I actually kind of sort of understood what it was, but I just never realized what it stood for. Anyways, let's get to the rules. We have apply classic Sudoku rules, which means for every cell inside the grid, place a single digit such that there from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region, which is a box. Digits outside the grid have to be placed in the same order in the corresponding row or column, but not necessarily in direct neighboring cells. For example, there may be other digits placed between the given digits outside the grid. So for row 1, we must see the 1, 2, and 4 in that order specifically. So it must be 1, 2, and 4, but it doesn't have to be next to each other. So this is a valid example of this Nonodoku, I guess. I don't even know what it is. But basically, you basically have, so the digits outside the grid must be in the order that it's specified in, right? So for row 1, it has to be 1, 2, and 4. It cannot be something like 2, 1, and 4. That is not valid because the order of those digits is not the same as what is outside of the grid. So for example, this must be, if you have for 8, 6, and 4 in column 1, it has to be the order 8, 6, and 4. Not 8. 8, 6, and 4. But it doesn't have to be next to each other. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. We have order 2358, 2358. That means 2 cannot be any of these digits because 358 at least has to be here. 2 can't be any of these digits. Where is 2 in box 6? It must be one of these digits. Similarly, 8 can't be here, and 8 can't be here, and 8 can't be here. Where is 8 in box 4? It has to be one of those 3 digits. Okay, does that tell us very much? Not particularly. Where can 4 be in row 1? 4 can be here in row 1. And it cannot be here in columns 1 or 2. But it could be here or here. Cannot be 4 here. This can't be 4 here. And this can't be... this could be 4 here. 3, 5, 4. Right? I'm not really sure how to approach this, actually, but... ones have to be the first ones. Okay, that's probably the better approach. 1 has to be one of the first digits in rows 1, 2, or 3 out of the 3 digits. That means 1 cannot be here. 1 has to be one of these 2 here. That means 3 has to be one of these 2 digits here, because 3 has to be in front of the 1. Okay. If this were 1, 3, and 9, that would not work, because this 1 would not have a 3 in front of it. So this can never be 1. Therefore, this is guaranteed to be the 1. This is 1, this is 4, that's 8. 8's here, so 6 has to be in front of that. Yeah, the reasoning, again, if this is 1, that's 3, 9, this 1 no longer has a 3 that's in front of it, so that doesn't work. So 3 has to be here, 1 is here, 4 and 8 are here. 3 could be here. 4 in row 1 cannot be here or here because that would be the first digit in there. So therefore, it must be one of these two, which means 2 must be one of these two, which means 1 has to be one of these two. That means 1 here has to be one of these. So 1 is one of these three. 3 has to be one of these. Okay, 3. Okay, so 2 can never be here because we know one of these digits is a 2, right? Because 4 can't be here, 4 can't be here, and 4 can't be here in row 1. So 2 has to be one of these two. So this can never be 2, 1 here. So this can't be 1. So 1 is one of these two, which means 3 cannot be here. So 3 is one of these two. 9 has to be one of these 3. Okay? Four cannot be the third digit here because we already have a 4 here designated. Therefore, since 4 can't be either of these columns, where is the 4 in row 2? It must be one of these two cells. So we have a 4 here and we have a 4 here. That means there's no more 4s in those columns. 8, 8 can no longer be here. So since 8 can't be here, that means 8 is at minimum here. So 8, 5, and 3 is minimum here. 8, 5, and 3 is the minimum here. Which means where is the 3 in box 6? Can't be here anymore. Can't be here. It must be here. So this is a 2, 3 pair. 3 cannot be here because the 3 has to be before the 1. So one of these two is a 3 here. What else do we have? Four cannot be either of these, or here, or here. Let's look at the rest of row 3. So it's 2, 3, 5, 6, 7, or 9, right? This can't be 2, 1, or 7 here. 1 can't be here because 1 has to be one of these two. Because the 2 can't be there. 2, I guess, could be here. But this can't be 7. One cannot be here. So that means 8 in column 6 has to be one of these digits here. 4, again, has to be one of these. And 4 has to be one of these for columns 1, 2, 5, and 6. Because 4 can no longer be any of these. What does that mean? I'm not sure. Oh, 3 has to be in front of 4 here. So this must be a 3, which makes that 4, which makes this a 2, because those are the only remaining digits left. These can't be 4, obviously, then. So 3 is here. That means 1 has to be in front of it. So 1 has to, and 1 cannot be here, so 1 has to be here, which means 7 has to be one of these digits here. Okay. Five has to be either here or here. If 5 were here, this would be 8, and that's not allowed. So 5 has to be here, which makes this 8. Therefore, this can't be 8 here. That means 8 has to be at least here, 5, 3. So 2 has to be one of these 3. 2 is one of these 3. 8 can be one of these 3. So 8 has to be one of these 3 then. 5 5 can be one of these three. 3 can be one of those three. Remaining digits in box 6 have to be 6, 7, and 9. And 6 cannot be here because it must be before the 8. So this is a 7-9 pair, which eliminates 7 and 9 in the rest of the column and the box, so this must be 6. We have 3, 1. Okay, so remaining digits in box 3 have to be 2, 3, 5, 7, 9, and 6. And 6 is here. 7, 9 cannot be here because of the 7, 9 pair in the column. 3 can't be any of these because one of these is 3. This can't be 2 or 5. So this is 3 with 7 or 9. 7 has to be one of these two digits, so this can't be 7 here. This becomes a 3, 9 pair here, which eliminates 3 and 9 in the rest of the column. Or, sorry, box. So this can't be 9 here. That means, can this ever be 3? If that's 3, the 9 is never going to be here. So this must be then 9. This is 3. That forces this to be 3 and this to be 1, because this can't be 1 because of the 2 there. So this is 1, 3, 9. These can't be 3 here. We don't know about 1, 2, 4 here. This is 1, this is 3. This is 9. This can never be 2 because the 2 has to be one of these digits. Neither can that. Okay. 1 can never be here, so this cannot be 8 here. Since this can't be 8, this can't be 5 here, and this can't be 3 here, and that can't be 2. So 8 cannot be here, because we know one of these two has to be an 8. So it has to be one of these 3, and the 4 has to be after it. So 4 cannot be either of these. 4 can't be here, 8 can't be here. So this is some combination of 8, 4 here. That means 4 has to be one of these two, which means 4 cannot be here. 4 has to be one of these two. And if it could be here if this is 2, and that's, so 4 can be either of these two. Since 4 is one of these two, 2 has to be one of these 3. And 8 can be here or here. We're not sure which. 2 cannot actually be here. So 2 can't be here. Where is the 2 in column 5? It has to be here. So this is 2, this is 8, which means this can't be 8. One of these is 4. That means this has to be 8 here. So this is 8, 5, 3, and 2. Guaranteed. 3 is not here. 5 is not here. 2 can't be any of these. And 2 can't be here. That means 2 and 3 have to be here. 2 cannot be here because it has to have a 3 in between that and the 5. 2 can't be here because of 2 in the column, so this is 2 here. 3 has to be one of these two. Cannot be here because of 3 in the column, so this is 3. That makes this 4. So this is done. This must be a 7 or a 9. So we finished this row. We finished that row. We finished this row. We finished this row. We finished this row. We finished this row. Columns. We have not finished any columns here. 2 is here, so this must be 1 and 7 here. So 1 is one of these digits, and 7 is one of those digits. So where is 7 in box 2? It must be one of these two cells, which means this can't be 7. This is 9, which makes that 7, which makes this 9. 8, 2, 4 is done. 1, 8, 4 is not quite done. So 1 has to be one of these 3, and 1, we know 1 has to be one of these two here. So that means 1 actually has to be one of these two. 1, 8, 4, 3, 1 is done. 7, 1, 3 is kind of done. 6 and 8 are kind of done. We're going to mark those as pink. 4 and 1 is not done. 2 and 9 is not done. 8 has to be one of these 3 digits here. That means 6 cannot be here or here. 6 has to be either here or through here. 8, 5, and 4, or sorry, it's 3, 5, and 4. This is 3, so 5 cannot be any of these. 5 has to be one of these, which means 4 has to be one of these two, which eliminates 4 in the rest of the box and column, so this can't be 4. This can't be, this could be 8. 3 is here. So 5 is here, 4 is one of these two. Where does that leave 4 in column 1? Can't be here, because you need 8 and 6 in front of it. Can't be here, can't be 4 here because of 4 in the row, so 4 must be here. So this is 4, which means 6 has to be in front of it, so 6 cannot be either of these. 6 has to be one of these two. This can't be 8 anymore, because if this were 8, there's no 6 between the 8 and the 4. So that means this has to be 8 here. So this is 8, which means this cannot be 8 here. So this is kind of done too. So 3 is kind of done. 8 and 7. 8 cannot be here, so this cannot be 7. So 7 has to be one of these 4. Not 4 doesn't have to be one of these 4. 8 has to be one of these 4. 4 cannot be either of these 4 digits. 4 can't be here. 4 can't be here. Therefore, we need a 4 and a 1 here. 4 can't be here, and 1 has to be... 1 can't be here, 1 can't be here, so this must be 1. 4 can't be here, so 4 must be here. So this is done now, too. 217's kind of done. 184 is not even really close to done, but I guess it's somewhat closer. I don't know. Remaining digits in box 5 are 5, 6, and 7 with 1. And 1 has to be one of these two. This can't be 7 because the 7 has to be after the 2. These can't be 7, so where is the 7 in box 5? It has to be here. Remaining digits in row 5, we have 1, 5, 6, 8, 9. 8 has to be one of these. This can never be 8. This could be 6. This cannot be 8 here. This could be 5. This can't be 5 here because the 5 has to be after the 3. 5 cannot be any of these digits. Whereas the 5 in... Okay, this can't be 5. It has to be one of these two in row 5. 8 could be here. Remaining digits in row 6 are 1, 6, and 7. So this could be 7, this could be 6. We know 7 has to be one of these two digits. 2 and 9. 9, okay, so remaining digits in column 7 have to be 7 and 8. Okay. Remaining digits in column 9 have to be 2, 3, 5. It cannot be 6 because 6 has to be one of these two digits. Remaining digits in column 8, 2, 5, 7, 9, 6. No 7 because of the 7, 8 pair in the box. This cannot be 2 here because that would be after a 9. This can't be 2 here because it would be after a 9. Okay. Remaining digits in box 2 have to be 4, 5, 6, 7, 9. Obviously 4 can't be here, 7 can't be here. We have a 4, 5, 6, 9 quadruplet in column 4, which eliminates 4, 5, 6, 9 in the rest of the column. Therefore, this must be 3, 1, and 7. This can't be 1, So since this can't be 1, where is the 1 in column 4? It must be here, which makes this a 7. That means this can't be 7 here. This is 8. This is 7. 4 has to be in front of the 7 in row 9. So 4 cannot be here. 4 cannot be here. That means 4 has to be here, which means this can't be 4 here. This can no longer be 7 because of the 7 in the row. Therefore, 8 cannot be either of these. 7 has to be one of these two. That forces this to be an 8. So this is 8, which means this cannot be 8. Seven could technically be any of these three. So 4, 7 is done. 2, 9 is not really done. 2 in row 8 can be any of these three. So that means 9 could be any of these digits. I mean, it's kind of done, but not really. 1, 8, 4. Where is 4 in row? Column 6. 4 can only be here. So this is 4. That means 8 has to be here. 1 has to be one of those two. We already knew that, though. So... 9 could be any of these three. Okay, so remaining digits. Okay, this 7 eliminates 7 here, so that's a 3. That means in column 5, we have remaining digits 5, 6, and 9. So any of those could be 5, 6, and 9. The last remaining digit in column 6 has to be a 2. So this is 2, which means none of these can be 2. Where is a 2 in box 9? It must be here. And this 3, 5 pair eliminates 3 and 5 in the rest of the column and the rest of the box. So this can't be 5. This must not be 5. This is 6, which forces this to be 2. This can no longer be 2. It's a 5, 7 pair here. This 9 eliminates 9 here. 6 can't be either of these because of the 6 in the row. We have a 5, 7, 5, 7 pair in row 1, which eliminates 5 and 7 in the rest of the row. This can't be 5. This becomes 1, 2, 4, and 9. But this can't be 2 or 4. This can't be 4, and this could be all of them. Okay, remaining digits in row 2 are 4, 5, 6, 7. And this can't be 5 because of the 5 in the column. Where is the 8, actually? We have 8 8s. We know where the last 8 has to be. It has to be here. So this is 8. That means 2 has to be this digit because it cannot, there's no other digit it can be. Can't be here because of the 2 in the column, and it has to be before the 9. Can't be here because of the 2 in the column. Can't be here because of 2 in the box. So this is 2, which means this cannot be 2. Where's a 2 in row 1? It must be here. So this is 2, which makes that a 1 in front of it. That means this can't be 1. This is 2. We should have all the 2s. Yep. We should have most of the 1s. Yep. Which means, where's the 1 in row 9? It has to be here. Because it cannot be here, it cannot be here. That means this can't be 1 here. 7's one of these two. That means 7 cannot be here. 5 can't be here. Where's the 5 in column 2? It has to be here. So this is 5. That means this cannot be 5. So 4 and 1's done. 2 and 9's pretty much done. 1 and 2, 4 is pretty much done. 3, 5, 4 is already done. 8 and 7's pretty much done. 2, 1, 7's done. That's done already. 1, 8, 4 is pretty much done. This is done. 7, 1, 3 is pretty much done. 6 and 8 is done. Okay, so now, probably just a lot of Sudoku now. This can't be 1 because of the 1 in the column. Remaining digits in column. Okay, so where's the 5 in column 1? Can't be here because of the 5 in the box. Can't be here because of the 5 in the box, so it must be here. So this is 5, which means this can't be 5. This can't be 5. Where's the 3 in box 1? Can't be here, can't be here, can't be here, so this must be 3 now. Remaining digits in column 1 are 3, 6, 7, 9. 7 cannot be here. 3 can't be here. 7 can't be here. Where's the 7 in column 1 then? It has to be here. So this is 7, which means this can't be 7. We need a 7 after this 8 in column 3, so this is 7, which means this is done. So that leaves this as, it cannot be 3. It's 6 or 9. So it's the 6, 9, 6, 9 pair here. 9 cannot be here because that would be in front of the 2. We have 1, 2, and we don't know what that is. Okay, so we have 1, 2 is done, 4's not, 1, 3, 9's done, 1, 4, 8's done, 2, 3, 5, 8's done, 3, 4's done, 2, 3, 5, 8's done, 4 and 1 are done, 2 and 9 are kind of done, 4 and 7 are done, 8, no, this has to be 6 because it has to be in between, so that's 6 and 4, which makes that 3, which makes that 9. The 6 eliminates 6 here, so this is 5. This can't be 5 or 6, so it's 1, which makes that 6. This 1 and 6 eliminates 1 and 6 here, so it's 9, which forces this to be 1. This 9 eliminates 9 here, so that's 6 and 9. 9 eliminates 9 here and here, so this is 6, that's 9. This 3 eliminates 3 here, it's 5 and 3. This can't be 5 or 9, so that's 3 in the corner. Celebrate, because we know we're getting close to solving it. This is 6, this is 5. 5 can no longer be here. This 6 eliminates 6 here, so this is 7. This can't be 7, so it's 5, which makes this 7, which makes that 5. This can't be 4 or 6 because of the 4, 6 pair in the row, so this is 7. This can't be 7 or 9, so it's 6, which makes this 4, which makes that 9, which makes that 4, which makes that 6, which makes that 9. And that's the solution. Fairly straightforward, actually. Yeah, you just have to think of the logic behind these, right? And what that eliminates. But we have 1, 2, 4, 1, 3, 9, 1, 4, 8, 2, 3, 5, 8, 3, 4, 2, 3, 5, 8, 4 and 1, 2 and 9, 4 and 7, 8, 6, 4. So I got kind of confused by this one because I didn't check the column very often, but 3, 5, and 4, 8, 7, 2, 1, 7, 8, 2, 4, 1, 8, 4, 3 and 1, 7, 1, 3, and 6 and 8. Pretty nice, actually. I could see these getting actually very hairy with the logic because even just like trying to wrap your brain around this one, which was fairly, it wasn't simple, but it was straightforward, I guess. There is still a lot of logic that could potentially be there, and it could be a lot of crazy logic also, I think. Anyways, I hope you enjoyed this solve for today, and I'll see you next time on Frank Puzzles. Take care.